unlocking innovation through robotics education. Welcome to our channel, Jay Robotics. In today's video, we'll delve into the fascinating world of distance measurement using an Arduino and ultrasonic sensor. Before we jump into the hands-on part of our project, let's quickly run through the list of components you'll need. An Arduino board, a breadboard, an ultrasonic sensor, and some jumper wires. These are the building blocks that will help us measure distance accurately. Make sure you have everything ready, and let's move on to the next phase. All right, team, buckle up. It's connection time. Grab your Arduino, LEDs, and ultrasonic sensor, and let's start by wiring up those LEDs. We're using LEDs 2 to 7, so grab those 6 LEDs. Connect the longer leg, anode, of each LED to digital pins 2 to 7 on the Arduino respectively. Now, connect the shorter leg, cathode, of each LED to the ground, GND, on the Arduino. This grounds the LEDs and completes the circuit. Now, let's shift our focus to the ultrasonic sensor. This amazing device has 3 pins: trig, echo, and VCC. Connect the trig pin to digital pin 12 on the Arduino. This pin is responsible for sending out ultrasonic waves. The echo pin, which receives the reflected waves, goes to digital pin 13. Make sure these connections are secure, as they play a crucial role in accurate distance measurement. Finally, the ultrasonic sensor needs power. Connect the VCC pin to the 5V pin on the Arduino, and ground the GND pin to the Arduino's ground pin. This powers up the sensor and establishes a common reference for the signals. Double-check your connections, make sure everything is snug, and we're all set for the next step. Before we upload the code, ensure you've selected the correct board and port. Go to Tools in the Arduino IDE, choose your board, for example, Arduino Uno, and select the port your Arduino is connected to. Now you can upload the provided code. Kudos on mastering the hardware connections. Now let's unravel the magic happening in our Arduino code. Our code orchestrates the ultrasonic sensor to measure distance. First, the trig pin triggers ultrasonic waves, and the echo pin records the time it takes for the waves to bounce back using pulse-in. This duration is then converted into centimeters. The real spectacle unfolds as the code activates LEDs based on specific distance ranges. For instance, if an object is within 7 cm, LED 1 lights up. If it's within 14 cm, LED 2 joins the party, and so on. This intricate dance between the ultrasonic sensor and LEDs beautifully visualizes the concept of distance measurement. Stay tuned for an immersive exploration of the code logic and get ready to witness this dynamic interplay in action. Your journey into the world of Arduino and distance sensing is well underway. I hope you enjoyed exploring the world of reed switches and Arduino with me. If you found this video helpful, don't forget to hit the like button, share it with your friends, and subscribe.